going to start week 4 with you, and this week we are in the kitchen. So if you're just joining us, my name is Dr. Erica, and sometimes my little sidekicks come to join me. This week they're going to join a lot of them, I think, because if you're baking something, we don't want to bake it twice. So this is Georgia and Isabella, if you've met them. They're pretty awesome. They're the best kids ever. And Evan is behind the TV screen. He is the person that is going to read out all of your shout outs or questions and comments. So if you want a shout out, type it in now. I know Venetia is the first one there, which is awesome. So she gets like the special first one shout out. Make sure if you're new to us that you like our YouTube page and you subscribe to it. You will get an email into your inbox every single day right before we start, just to help you remember we have it and get all of the supplies that you need. So I'm going to go through what supplies we need today while everybody puts in who's here, and we will get to our shout outs, and then we'll get our project started. And we actually have one of our projects we're going to look at from last week. And if you're new, you can come and go as you want. So if like Monday, Wednesday, Friday works really well for you, come join us Monday, Wednesday, Friday. And if we start an experiment on Tuesday and it takes a long time, you'll get to see the experiments in action. So these are some experiments we started last week that we're going to check in on because they need to get taken care of. All right, so today we have 2 projects that we're going to do. We are going to start some sourdough starters. And to do that, you'll need a jar for each starter that you're going to do. You need maybe a measuring cup. A scale is actually preferable, but we're going to use the cup to just scoop the flour. So a kitchen scale if possible. You're going to need some water. You're going to need some flour. Kitchen towel is great, and if you want to try one with raisin yeast, you can have some raisins, or any dried fruit will work. Any fruit will work, except for we kind of don't want to not wash our fruit nowadays. So if you wash your fruit, you're going to wash off all of the yeast. So if you have other dried fruits, that you can totally use that. So that's what you need to start our sourdough starter, and we'll actually be doing that in the beginning of class every single day this week. And then the other thing we're going to do today is we get to learn about phase transitions and melting and solids. And we're going to do that by calibrating our oven with sugar. So to do that, you'll need sugar. You don't even need a measuring spoon, just a spoon to scoop your sugar with. You need some aluminum foil. You're going to need your hot pads because nobody wants to pull something out of the oven without hot pads. And then you're going to need some sort of baking dish for everybody who's going to do it. And right now, if you can, you want to go preheat your oven to 350 degrees Fahrenheit. I think everybody we have here is on the non-metric scale. What does that convert to? I can't think of it really fast off the top of my head. That's like 186 degrees Celsius, I think. But we want to get our ovens just sort of preheated so that we can get started on that once we are ready. All right, who do we have for shout outs?
It's 176 degrees.
176 degrees Celsius. That was a pretty good conversion in my head, though.
All right. Well, of course we have Venetia.
Venetia's here, of course, because she was first. That's exciting.
And then we have
Venetia.
the Goods. They're early birds too.
Yay! Hello, good family.
And the Hertz are also they're
Yes.
number 3, man.
Hello, Hertz. I love that like everybody's getting in.
And we have Naomi's here. Hi, Naomi.
Hello, Naomi. It's good to see you.
And Luke and Ryan would like a shout out.
Oh, hello, Luke and Ryan. Are these siblings, Luke and Ryan, or Luke and Ryan?
They're in one. They must be siblings.
They must be. Ooh, very cool.
And Connor and Grayson.
Hi, Connor and Grayson.
Connor brought his little brother, it looks like.
You know what? Connor has a sister, an older sister. So Grayson must be the older sister.
Cool.
Maybe.
George and Henry, say hi.
Hi, George and Henry. Oh, I love. They've been here like I don't think they've missed today. Have they missed today?
I don't think so.
They missed today. George and Henry.
Elsa's here.
Hello, Elsa, and probably Lauren.
And Amelia and Chloe, but no Calvin.
Oh, hi, Amelia and Chloe. Hopefully Calvin feels all right.
And we have, there's a lot more down there. Elliot's here.
Hello, Elliot. How are you today?
And Abel is here.
Yay! Abel's back.
And Kavi's here.
Hello, Kavi.
And he's got good news.
Ooh, good news.
He made it to 8 years old.
I was going to say, it's your birthday, right? Oh, super exciting. I love it. Happy birthday, Kavi. Big 8. That's a big deal. That's a bubbly number.
And it looks like Kailani and Keikoa are here.
Kailani and Keikoa, hello!
Well, you
Oh,
should
that's
say
exciting.
hi,
That's their first time coming and joining us. Yes.
And Carter and Harrison.
Hello, Carter and Harrison.
And Tamsin and Laurel.
Ooh, Tamsin and Laurel. And I actually have a visual reference for who you guys are. I'm going to remember your names in Zoom today.
Ooh.
It's really hard because we have so many new people. And I'm trying to remember everybody. That's like my goal in my in-person classes. I'm really good at that. It's a little trickier on Zoom. But I know who Tamsin and Laurel are. I can connect with your faces, ladies.
And Anaya here, and it is her first class. She's very excited.
Anaya?
Anaya.
Anaya, did we say it right? I hope we said it right. Maybe. We'll find out.
Anaya.
Anaya. And
we'll
find out.
The Washels.
Oh, the Washels are here.
Washels.
Hello, ladies. All right. Shall we get started? So the first thing we are going to do is we're going to learn about melting. And this project takes a little bit of time. So we're going to get it set up first, and then we'll learn what's happening, and we'll check in on it. And we'll probably have to change the temperature. And then while we're like waiting for that to happen, we'll do our sourdough starter. Does that sound good? Mm-hmm. All right. So this is what we need to do to calibrate our oven with sugar. You guys have your stoves set to 350 degrees Fahrenheit or 176 degrees Celsius. And what we're going to do is you guys are going to take a little bit of foil and you're going to put it inside of your baking pan. All right, so Isabella, why don't you take a piece of foil? You're just going to smash it down. Wesley? Wesley. Ooh, I did it wrong. I'm sorry. Wesley. I like that. All right, so Isabella is ripping off her piece of foil. Ooh. Why don't we hold it this way and then pull from the top? And you sort of pull down at an angle. Much better. And you're going to stuff that in there. Georgia, are you going to come and do this project with us? All right, I'm going to rip off Georgia's foil for her. And I'll put it in here. So you don't even need to oil our foil. We're just going to smash it in. And then all you need to do is add like a tablespoon or two of sugar onto it. And you don't necessarily, you can mound it if you want to, but you could also just sort of like flatten it out a little bit. Not like all the way so that you have like one crystal of sugar every spot, but we want it to be like a nice little area. Isabella's doing too, because she knows that this makes tasty candy.
So I get to eat it.
And she wants to eat it.
We have
so we got that.
One of our families Naomi couldn't get foil, but it has a baking mat or parchment paper.
Yeah, either of those would work. Silpat, baking mats, more like baking mats, or parchment paper should actually work great.
Guess who's back?
So you're gonna put in two. Hi, Raven! Oh, I'm super excited you're back. Yay! I feel like I missed you a couple days last week. Maybe I'm wrong. Maybe it was just a long weekend. I don't know. All right, so I think both my girls will probably want to add two also. Fantastic.
Nice.
No, we just two is really going to be plenty.
Hey, Erica, what is in the PDF?
Oh, in the PDF is the instructions on how to do this sort of on your own. But if you're doing it with us, you probably don't need it. There are some common cool questions in the PDFs that I answered. But yeah, if you're live with us, you can leave that PDF behind this week. There's not a whole lot to fill in on the PDFs. It's really just, what do you need? How do you do it? Here's some common questions.
How much sugar did you say?
So my girls use 2 tablespoons of sugar, but you could use 1 tablespoon. I wouldn't do like tons of sugar just because then you're going to be wasting a lot of sugar. But I don't know. I would try it first with like maybe a couple tablespoons. And then if you decide this is amazing, you guys can do this as a fun project later. All right, so I kind of want to show you guys Georgia's, but it's going to like sort of slide down. So it's sort of like a little bit deep, you know, it's not like super thin. And she's got like a pile, but it's not like a big mound. So that's kind of what you want. That's what we want.
This line?
Yep, just like what Isabella's is looking the same way. So it's sort of like this, I don't know if I can get the angle right without the sugar falling, but it's sort of like this nice little pond of sugar.
Powdered sugar?
Powdered sugar. Ooh, powdered sugar should work. Because powdered sugar is just crushed up sugar crystals. But it might melt. I don't know. I think actually that would have been a great question. Like, it will still melt. Will it melt at a faster rate? I mean, it'll melt at the same temperature, but will like the, like if you take ice and it like an ice cube, it takes a long time for a big ice cube to melt. But if you have crushed ice, then it takes less time.
Naomi may have to be our experimenter.
Yes, Naomi. Oh, I love it when we have an experimenter. All right, we are going to take these over to our oven, and we're just going to pop them into the oven. If your oven's warming up still, that's fine. You can still pop it in because 350 degrees should be less than the melting temperature of sugar. So if your oven is calibrated correctly, nothing should be 350 degrees. If it runs hot, which actually I think ours does, it might melt at 350 degrees because what is telling me on the knob of 350 might actually be higher. But we're going to find out. That's what we get to do today.
The Wesleys use 2 cups.
Of sugar? 2 cups of sugar? Oh, you guys are going to have some delicious candy. I love it. All right, we're going to take ours and we're going to pop it over into the oven. Girls, do you want to do that?
Yes.
All right, my girls are going to go pop it into the oven.
Wait, this is brilliant. No, it's not.
Nope, I think yours is in the blue. And we can put one on the top shelf, girls, and one on the bottom shelf. We got to be careful with our hands.
What about the pizza thing?
You just put it on top of our pizza thing. Let's plop that in. Get yours in there.
My hands are hot.
There we go. Beautiful. And so we're just going to plop these in. And we're going to wait. All right. So as we wait, we can learn about melting. And you guys probably have a great idea of what melting is. Oh, actually, before we learn about melting, we wanted to check in with this project we did last week. And I really want to check in with it because it's getting moldy. And that's just gross. I don't want moldy things in my kitchen. So last week we did the human body, and one of the days we did digestion. And we looked at pineapple because pineapple actually has an enzyme, and we talked about how enzymes are like little scissors. And these scissors never run out, and they break through animal proteins. And so we put pineapple on top of gelatin to see what would happen. We have a question. Let's see.
Raiden is asking how thin his sugar needs to be.
It doesn't need to be super thin, like maybe like something like, I don't know, less than a centimeter thick, but maybe like a couple millimeters thick. Something that you could like poke your finger in and it makes like a teeny tiny mound around your finger would be good. Yeah. All right. So we did an experiment where we made gelatin, which is an animal protein, and the protein sort of makes this matrix that hugs water. And we put in some enzymes, and we put in pineapple, which sadly, after we had the pineapple, we had an incident where we ate too much pineapple, which you might have done before, and it hurts your mouth when that happens. It's never any fun. And that's because the enzyme is actually chewing up with scissors on your mouth, which is no fun. So we did pineapple, which we looked at, and you can actually see how much liquid is inside of this. I mean, it's eaten through half of the gelatin. You got a question, Georgia?
I've had that to me on my tongue.
Yep, Georgia has had that happen to her, and it was like no fun. And you can't really do much. Like drinking milk doesn't deactivate that enzyme. It still is like, oh, milk, okay, whatever. And it keeps cutting stuff through. So like rinsing out your mouth would help. But as you can see, these guys we started on Tuesday, and it's really been eating through like half of this big thing of gelatin. And that's just like a few slices of pineapple that you can see, which is really watery in there. And we also tested at the same time something called meat tenderizer, which is like a spice you can get in the spice aisle. And that's actually pure bromelain. And bromelain is the same enzyme that's inside of the pineapple. And you can see that this has also got all this liquid. So I didn't add any liquid. We started with all hard gelatin. We didn't add any liquid to it. So all this liquid is from that enzyme chopping up those proteins and releasing the water. So this one is also a lot. Although if I look at the two, it sort of looks like maybe that's because the pineapple is inside the water, raising the water level. But I kind of feel like the pineapple did a better job. And we also learned that if we add heat, sometimes it breaks those scissors so they can't scissor anymore. So we cooked some pineapple, and this is the reason why we're going to stop this experiment. Because our cooked pineapple didn't do anything. You'll notice there's no water here. It's completely dry, but it's also really disgusting and moldy. And that happens because we have this great medium to grow things, and the little tiny bacteria and molds are like, ooh, yum! And they're really happy. But we can see that the enzyme didn't do anything because we cut we broke our scissors, which is cool.
Just to note, that's what the gel looked like before. It
Yes.
was stiff like that. It didn't move at all.
Yeah.
Now, if you compare it to the other ones.
So if you compare the 2 pineapples, I can't even hold this one up because it's going to spill out. But if we compare the 2, they all started looking like this, I think, on Tuesday. So this is about a week later. We have all this liquid. So this enzyme is really chewing that up. And it will keep doing that. The enzymes never run out. So the scissors just keep going. Not like they have a certain amount that they can do. So that's sort of a fun project we started last week. And we won't check in on this one again because one of them is getting moldy and that's gross. So we're going to clean these guys out later on today. All right. So,
how long do they want the...
Oh, we're going to leave it in for like 10, 15 minutes. Yeah. All right. So melting. Our sugar is in there. It's warming up. But if your oven is actually at 350 degrees, like we think it's at, your sugar shouldn't melt. So sugar is like this big molecule. It looks just like this. And it's a whole bunch of these molecules stuck together, and they stick together. They hold the other molecule's hands through what's called a hydrogen bond. And if we add in energy to a system, things get jiggly, right? Like if I were to like sit a whole bunch of students, like really in this perfect grid, and it was like a crystal, and I was like, everybody has to sit still, and the students were like this, that would be like a perfect solid. And then if I like, I don't know, if I maybe added a little bit of candy could be our heat in the system. All the kids, and I was like, you can't eat your candy. They might just like look at it and be like, oh man. And you see how they're moving around. They're like, ooh, interesting. So we added a little energy in. And then if I put a whole slice of cake, they might be like, what? Oh my gosh. And they might be like, dude, did you see that cake? Oh my gosh, isn't that cake so good? It's so good. Oh my gosh, I love it. And they're like moving around a little bit. And then if I added like something else, I don't know, what would be even more amazing than cake?
Brownies and ice cream.
Okay, so now.
And Tony's.
Okay, so now I'm going to add a platter that's got brownies, warm brownies.
Yeah.
Warm brownies.
With the gooey inside.
Yes, and ice cream and Tony's chocolate and everything you possibly want. The kids are not going to just sit there. You're probably going to be like, yes! And they might be like running around the class and be like, oh my God, there's brownies! And they're now liquid because they got up from their seats and they stopped being motionless and they're moving around, right? So similar thing is happening with this sugar when we're adding heat. So the way that they're actually held together, they're going to start to be like a little excited, but at 350 degrees, they're not shouting. They just have like a tiny marshmallow on their desks and they're like not shouting for joy, but they're sort of like, ooh, this is exciting. What's going to happen today? And they're moving around a little bit and hopefully they still stay in their seats. If your oven runs hot, they actually might get out of their seats and jump for joy because we might have thought we put on a tiny little bit of a marshmallow and we might have really added that huge brownie a la mode craziness. So they might get out, and if they get out and they're like, yes, that means they melted into a liquid. Another thing that melts that we know of is water. Now water, we don't need to bake to melt, do we? Georgia, what do we have to do to melt water?
To make water?
To melt ice, which is solid water.
You have to make it hot. So this is like a hot pond.
Mm-hmm.
This is a hot pond. You can put it in that hot pond for a little bit,
and it'll melt.
And then it'll turn into a bigger pond.
Yes. So Georgia's got this idea where if I take ice and I put it into a warm pond, it'll melt and we'll get more of a pond because we'll have more water, which is totally right. Do I even need to have something warm compared to where we're at right now to melt ice?
No.
I could just put it on the table and melt ice. So for ice, they don't need much. They're like super excited about that marshmallow. They are like so excited. They are running around for that marshmallow.
That ginormous marshmallow.
Yeah. No, it's just a little marshmallow and water gets excited, man. They get so excited. They're jumping out of their seats.
Like the marshmallow molecule.
Yes, because look, it's a much smaller molecule and they actually have 4 hydrogen bonds. So when we add just a little bit of heat, we actually melt the ice. Whereas sugar, way more complex. We got to add a lot more heat. There are some things that still melt that you have to add a ridiculous amount of heat. One of those things is in your house. Ooh, I can actually maybe smell our sugar. I think our oven is really hot. Salt will also melt, but salt doesn't have those hydrogen bonds. So it's not easy to melt salt. You really, like, giving them a brownie a la mode does not does not get salt to jump out of its seats. In fact, for salt, you have to really like, you have to be like, you're winning a brand new car. And they're like, yeah, car. It takes like 1,700 degrees.
Maybe a ginormous stuffy, bigger than that.
Yes. You know, it's like, salt, come on down, right? Salt, you have to add in so much heat. You got to add in, it's like 1,750 degrees, I think, is where salt melts. So your oven cannot melt salt, not useful. And also you can't do oven calibration with ice because ice would just melt at room temperature. So I'm actually smelling our sugar. So we're gonna pop on over there and we're gonna check our sugar to see, because I think our oven runs really hot. So it's telling me we're at 350 degrees and woo, we are smoking. So we're gonna try this again because our oven is so hot that at 350 degrees, you'll notice it's actually burning, and I can know it's burning. We don't want to touch it. You never want to touch melted sugar until it's hard again. But I know it's burning because it's brown, which means it actually has lost some of its water. So it's no longer just melted. We can't turn it back into sugar. So we're going to turn our oven down. If you check on yours and yours is melted, awesome. If it's like melted and like just starting to melt, that means that your oven runs a little bit hot. If it is, here, why don't you come this way, Belly? Because the camera's right there. If it is not melted yet, you could turn yours up to like 375 degrees where it should start to melt. If you have a situation where we have, where 350 degrees is so hot that it doesn't even melt. Ooh, actually, look at this.
What?
Here's Georgia's. So the bottom of our oven is actually far hotter than 350 degrees.
Also,
The top of our oven is totally okay still.
well, it's also because the pizza starter is absorbing most of the heat right now. Still.
Yeah, so we're gonna keep Georgia's in. And Isabella, we'll make some more for you later.
Do I get
All right.
the candy still?
Yeah, we'll make some more candy for it. We're gonna make some more candy for Isabella later.
I'll put it in the freezer and then make it.
Oh, so we are going to turn our oven up just a little bit.
To what?
So you can go, if you want to make the jump to 375, you can. Sugar will melt at like just about 365 degrees. So I'm actually going to shoot the middle between 350 and 375 on our oven, and we'll see.
But didn't ours
Wait,
melt
that's
at
good.
350?
Why is that good?
Our bottom rack melted at 350.
Good.
Burnt.
What's that?
Would you? Yeah. So we need to raise it a little bit so it'll melt in a little bit. No. Evan's thinking 350. We're going to keep ours at 350. But you can check in on yours and see.
Can I
We
put
have
mine
some
in
people
the
who
freezer?
checked it.
Oh,
Yes. Anybody's melt.
We have Venetia's
Georgia.
is melting around the edges.
Venetia, it's melting around the edges. Perfect. Do not touch your oven, Venetia. Let it continue to melt just like that. So if the outside edges are melting, that means that your oven is actually at that. It's like a little hot. It's actually at 365 degrees or so. So yours is perfect. Don't change your oven higher. Just give it a little bit more time.
And then
Can I put mine in the freezer?
Putting it in the freezer is not going to change it because we've actually burnt yours.
Can I?
And
hold
burning
it?
and melting are different. It'll harden at room temperature. So yeah, once you pull your melted sugar out, you just want it to sit at room temperature for a little bit and it'll melt.
the Hertz melted completely.
Oh, now here's a question for the Hertz. Did it melt and it's still sort of clearish, or did it melt and it looked like Isabella's where it's just a black blob? Because we're going to talk about the difference. Isabella's went too far and is no longer melted sugar. Hers is burnt sugar, which is slightly different.
And the Wesley's didn't melt at all, so they're going up to 370.
Perfect. Yeah. So if it didn't melt at all, you can knock it up a little bit and see.
The Hertz said clear.
Clear. So your guys' oven for the Hertz, you put it at 350 and we waited and it melted yours. It's clear. Your oven runs about 15 degrees hot. So it shouldn't have melted at 350. It should melt at 365 degrees. So for the Hertz, now they know if a cookie recipe says 400 degrees, they probably really want to put their cookies at like 385 degrees so that their cookies cook the way whoever wrote the recipe thinks it will cook. So it's really handy to do something like that so that you know, so their oven runs a little bit hot. Some of you guys will probably find out my sugar doesn't melt until I'm at like 380 degrees, in which case your oven would run cold. So we're actually going to leave ours in at 350 for a little bit longer and see if Georgia's on the top rack melts. And in the meantime, I want to talk about, I mentioned, oh, hang on. We've got a great comment.
Brayden says his didn't melt yet.
Okay.
The Lindbergh say they're going to 370. And the Hertz say mom burns everything. Now we know why.
See, it wasn't your mom's fault. It was the oven's fault. Perfect. All of us moms are going to like, we've got a cover now. It's great.
It's always the oven.
They put their
always the
mom
oven.
under the bus.
They didn't put their mom under the bus. Now they know why. It's their oven. Their oven is throwing their mom under the bus.
Elliot has a question. He asks, how hot do common ovens get? How hot can ovens get is my follow-up question.
So common ovens, usually they'll go up to like 500 degrees. Whether they make it to 500 or not is sort of questionable. Now 500 degrees won't melt something like, say, metal. And we do know we can melt metal because a long time ago, we used to make weapons out of metal, even still now. And what people would do, right, is you would melt the metal and then like whack it into a sword shape. So those would use ovens too. They would be different types of ovens that would go much, much higher. So like a kiln. Yeah, a kiln is sort of like a type of oven. So like the oven in your house probably goes up to like 450, 500 degrees. But then there are industrial ovens that are made to go really, really high, right? And then there's ovens that are in science labs that can do things like melt metal, melt gold, melt salt, melt these things that have really, really high melting temperatures. I think the highest melting temperature is like a tungsten. It's like tungsten mixed with some things, and it's like over 7,500 degrees Fahrenheit, which is like really hard to even fathom. And so obviously if we know that it melts at a temperature, we've made an oven that goes up to 7,600 plus degrees. So we can go really, really high, but not the one in your house. Your house goes up to like 400 to 500 degrees.
We have some more updates.
Yeah. Ooh, updates. Good.
Naomi says their powder did not melt at 350. At 365, it started to melt light brown.
Perfect. So that's a little bit hot. So if you want to back it off to like maybe 360, but your oven is running really good. So ideally when it melts, it should melt and it should be clear, kind of like the Hertz's. Because if we add too much energy in, what happens is we actually start evaporating some of the water and changing the structure of that sugar, which is what makes it go sort of light brown and then a darker brown, and it's like burning. And the reason why I say burning and not melting is because melting means I have the same structure. So when I take ice is 2 hydrogens, 1 oxygen, right? And I can melt it into water. Water is 2 hydrogens, 1 oxygen. I could even heat it up more. I could give the water a car, and the water would be so excited it would go to steam, but the steam is still 2 hydrogens, 1 oxygen. So it's always looking the same, right? With sugar, I can take this sugar molecule and I can add heat and I can keep it the same. I can break the bonds between the other ones that are in that little sugar crystal we had. But if I add too much, I'll actually start breaking some of the bonds between these 2 little rings, in which case it's no longer the same. And that's why you get this like burning, right? So if something changes its structure, it burns instead of melts. In fact, wood, there's always this big question. Could I melt wood? Because there are some things in this world that do not melt. And the definition of melting means it looks the same, like on a molecular structure before and after. So H2O is still H2O is still H2O. Whether it's ice or water or steam, still H2O. Or like the sugar is going to be sugar no matter what. I can't make sugar steam. I can't make a gas of sugar because to heat it up more, we just saw that I changed the structure. I broke some extra bonds and it was no longer the sugar we had initially. So I can't actually do the next phase transition to get sugar into a gas. But with wood is like so much stuff. Oh my goodness. Like this is like, there's some pieces of wood that look like this, and then these guys link to pieces that look like this, which is, oh my gosh, so much stuff, which links to some that look like this. There is so much stuff in wood. And what happens is some of these things break down before the whole of it breaks down, which means it burns instead of melting. So if it melted, we'd have to have all of this stuff still locked together in the exact same conformation as we add heat, even if there's no oxygen. So oxygen is what makes a lot of things burn. Even if we did this in a vacuum, it would still decompose into smaller pieces because we would still break some of these extra little tiny bonds. And that would then make it so we can't melt wood. So you can't even melt wood in a vacuum in space or anything like that. Evan has a question from one of you guys.
All right, so we have Venetia says it's clear orange-ish.
Perfect.
And the Weshleys ask, what is it supposed to look like?
The melted sugar?
Yeah.
Yeah, so it should look like almost like a window pane. It won't be like super clear because you might have some bubbles. But it sounds like we've got some people who are clear and then some people who are starting to brown a little bit, which means you're like right there. And maybe you sort of overshot that reaction a little bit, but you're right there. But then Isabella's was like black.
We have
Hers doesn't look great.
The Weshleys say theirs is brown but not burnt.
Okay.
We have the Hertz say that theirs looks like maple syrup.
And that will actually, when you cool it, that will dry, it will harden, and it will turn into sugar glass. Like, just imagine glass made out of sugar, and that's what it's going to be.
And then
it's delicious. It's so good.
The Hertz say theirs look like maple syrup. Rachel's here. Rachel and Jennifer.
Hi, Rachel!
Theirs is melting around the edges. They caught up.
Perfect.
They got here.
Good. Yeah, so Isabella's, she's asking me, is it sugar glass now? It's just burnt. So this is like, if it looks like this dark, you don't want to eat it. It's going to just taste like carbon. Like all of the stuff that's in here, we've actually broken that sugar molecule down. We've taken a lot of the water out, so it's going to be gross. And Georgia is going to share with you. That's so nice of you. Thanks, Georgia. We should check in on Georgia's. We're going to go check in on Georgia's, and then we're going to, if hers is not melted yet, we're going to raise the temperature a little bit, and then we're going to start our sourdough starters.
Can you touch it yet?
Let's go. Can you touch it yet? Yeah, you can touch it because it's not too hot, but it's hard.
Daddy?
Yeah.
So Isabella's, you can touch in it, but it's like rock.
Kavi is asking, what does burnt mean on a molecular level?
Yeah, so burnt means that we have broken bonds that were in that molecule. So it would be like,
It's not melting, but we can take it on.
yeah, so Georgia's is not melting.
The on the side.
Ooh, on the side. So Georgia, we're gonna leave yours just like that.
It's yellow.
Yeah, so it's starting to go. So we're gonna wait. Georgia's is getting a little bit melted.
I turned it up a little bit. We're probably at
You could, but you're gonna really not like it.
55, 360.
So Kavi was wondering on a molecular level, what does burning mean? And that's when we use some oxygen, usually in the air, and it combines with some of the stuff, and it basically pulls things away from the molecular structure that we had before, and it combines with the oxygen usually to make like water and carbon dioxide, and then like we have extra carbons, which is why it usually looks very, very dark when you burn things, which is gross. So you don't want to eat it.
Abel is saying that his is not melting at 375.
Ooh, Abel, interesting. Maybe leave it in there for a few more minutes at 375 and then bump it up, which means your oven runs cold. So I'm curious if your mom bakes a lot of stuff and they always come out doughy, which, let's be honest, is maybe not a problem. Like doughy cookies, doughy brownies, not a problem in our house. All right, let's leave that for now.
So then Kavi has a follow-up. He says, what is smoke? Before you get to that, Amelia's asking if using organic sugar has a difference.
Using organic sugar would not have a difference. It might change the color because organic sugar is slightly darker brown because this hasn't been as processed. So it would change the color of your sugar glass, but it won't change the fact that the sugar, table sugar, and organic table sugar are still the same molecule. So it's still organic sugar and table sugar still look like this. It just depends on like sort of like what other things like it's been treated with before it gets to your table. What is smoke? That's a great question. I want to maybe answer that tomorrow. I'm pretty sure it's just carbon molecules that are sort of like clumping together, and it's like tiny bits of carbon that are coming out, but I'm not 100% positive on that. So I'm going to take your question offline. I'm going to research that for you and double check because I'm pretty sure it's just the carbon burning off, like the carbon's getting so hot, like carbon steam. But I'm not 100% positive on that. So I want to check that.
So Raiden said, it's melting.
Perfect, Raiden.
But then right after that, he said it's done.
Okay. Yeah, take it out once it melts, and then you're going to let it cool, and you'll have your sugar glass candy.
And then Calero and Sky just joined us.
Oh, hello, Calero and Sky. I'm glad you're joining us. All right. We are going to also start Sourdough Starter.
Brown sugar question?
Ooh, brown sugar actually is white sugar, and it's white sugar that has been treated with molasses. So you can actually make your own brown sugar at home. And I kind of feel like molasses is basically liquid browned sugar. So I think brown sugar will burn because you have that extra piece on top that's going to do it. George is really excited because it's working on hers at 350. Are we still at 350?
No, I moved it up to around 355, 360.
All right, so we moved ours up a little bit. So maybe our oven is dead on. I don't have an excuse for burning things.
Venetia tried it.
Yes.
And it tasted burnt. So they want to redo it.
Yeah, definitely redo it and maybe wait longer at that lower temperature.
We have one who melted exactly at 365, the Hextads, and
Nice.
Alex did. And then the Wolves melted at 370. And
Nice. We all have really well calibrated ovens.
Tamsin says, it looks like honey.
Duh, I know, and it's so good when you, yummy. In fact, you can use this when you bake gingerbread cookies because like a lot of times they'll put in like sugar glass. Don't use colored sugar though. Colored sugar like has all those dyes and those will burn and it'll just be gross. But sometimes if you like make cutouts in like cookies, you can like fill it with a little sugar and then the sugar will melt as your cookie is baking. And you get like a cookie with like a glass window, which is super cool. All right. So while Georgia's is still finishing, and if yours is still finishing, awesome. If it's not, awesome. We're going to start our sourdough starter. So one thing that I've always wanted to do my whole life is to make sourdough starter. And I have never made it because it takes a long time. And then we were like doing this kitchen stuff. And I was like, I'm going to be live at 11:30 every single day for the next 5 days. And we can just do it as part of our like, oh yeah, yesterday continuing project thing. We can just do that. And then we'll all have sourdough starter, which is awesome. And it seems super easy to make. So I've researched 2 recipes and we're going to try them both to see which one works better. Now I do know some of my friends are gluten-free. So when we're using flour, you just want to use your gluten-free flour mix. It will work because sourdough bread mix, the only thing we're trying to get from sourdough is wild yeast. So normally we buy yeast in those little packets that are at the store. You just buy it and it's all measured and you're baking your bread and it says 1 packet of yeast. You rip it in, you pour it in and you're good to go. Wild yeast, however, is like everywhere. It is in the air we breathe. It is on these raisins. It is on everything. It's even inside the flour that we use. But it just isn't activated as much as commercial yeast is activated. There's not as much yeast in here as when you use a packet of yeast, which like a packet of yeast has like billions and billions of yeast cells. So there's a lot more and it gets bubbly really fast. We're going to have to nurse our yeast cells and give them like a nice, happy, warm place to live for the next week or so. And they're going to have all of their babies and their babies are going to have babies. And then we're going to get billions and billions of yeast cells inside of our sourdough. But it won't be commercial yeast. It'll be called wild yeast. So one of the ways that we've said this, when I looked, was literally just mix equal weights of water and flour. Now you can't use a measuring cup for that because flour, like a half a cup of flour, weighs much less than a half a cup of water because water is really, really dense. It weighs a lot, like for each half cup size, it weighs a lot more than flour. So we're going to use a kitchen scale and we're going to just use the half thing scoop to figure out how much we've added in. All right, so Isabella, you're going to get to do this guy. And then Georgia, you can do the one with the raisins in it, okay? So what we're going to do is we're going to put our jar on the scale and it'll be zeroed. It went under, yeah, because it was a liquid for a little bit. And we're going to add in like maybe 200 grams of flour and then we'll try to do 200 grams of water. It's probably not very good. You can try it,
I guess.
So don't pour the whole thing. Let's just do like 200 grams. We're going to change to grams. All right, go for it. Let's see what we got here. I'm going to be a hand funnel for Isabella. Going. Oh, yeah, we're at 60 grams. All right, maybe we'll do 100 grams. Hang on, we're going to pour some of this in here. And
what does candy supposed to taste like?
all right, let's go for 100 grams. Here, do you want to use the tablespoon?
Mama,
Yeah, just
is
a little
what
bit.
it's supposed to taste like?
No, ours, when we're on the bottom, it burnt. So that's not what it's supposed to taste like. All right, so we're slowly getting up to 100 grams of flour, and then we'll add 100 grams of water. You don't have to add 100 grams. You could add 5 ounces of water and 5 ounces of flour, or 2 ounces of flour and 2 ounces of water, or 100 or 50 grams of each. We just want about the same amount of weight for each one. And you're going to put it into a jar. I believe you want it to not be metal. So glass jar, plastic jar should both work. Just not metal. All right, ooh, we're getting close. We're at 89, 90, 92. That's okay. It doesn't have to be exact.
Oh, do you want to see it?
All right. Oh, George's has just come out, and it's a liquid. Oh, it looks good.
Oh, we're gonna want it.
It looks super good. We don't want to touch it right now because it's really, really hot, and it will burn you. So let's let that guy cool. All right. Add a little bit more, Belly. Yep, you'll get it when it cools. Georgia, you're going to add a scoop of raisins in there first. Just like add a little handful of raisins. All right, that's close enough. 97 is close enough.
Like that much?
All right, and then you're going to add about 100 grams of this. The water. Let's add a little bit more.
So to 200?
Yeah, but maybe do it by tablespoons.
Yeah. Do that.
Let's add a little bit at a time. Or you can do it like
we have
this.
somebody said they don't have a scale. Can we give estimates on how many cups we need? Or
Yeah, we can. Let me look at what we're getting.
Yummy.
I'm going to probably guess like maybe it's like a 2 to 1. Let's see what we end up with though. Yeah, I'm going to guess like 2 to 1. So like 2 parts flour to 1 part water is going to be my guess. And it's not going to be like, it's okay if it's not perfect. Yeah, that's great. All right, so you're going to go grab a spoon and we're going to mix it up. And then we're just going to let Isabella's hang out. Georgia's, she's added a little bit of raisins. And there's a bunch of yeast on any fruit. And then when you dry it, you get even more yeast on your fruit. So what we're going to do is we're actually going to add in about 100 grams of water on top of this. We're going to zero our scale with the raisins in there. Question.
Craisins?
Yeah, any dried fruit should work for you. If you want to do this one. And again, you don't even need it. You can just mix it up. So Georgia, you're going to add in until we see 100 on here. So it's not going to be very much. Whoop, whoop, whoop. That's okay. All right, we're at 150. That's okay. So we're gonna, why don't you swirl it around?
Makes like a doughy thing.
And then we're gonna add in 150 grams on Georgia's of flour, and we'll mix that all up. And we'll see how both of these starters work. For now, it's not gonna do very much at all. What we're gonna expect to see, we wanna keep it warm. So if you want to just like hold on to it like it's a little baby because it's alive, you can. Or set it somewhere in your kitchen that's like cozy. So maybe by your stove. You don't want it to be hot. So you don't want it to cook the flour. We just want it to be like cozy and happy. So like 75, 80 degrees is like a great guy for our flour. Georgia, did you want to add your flour into your raisins? Or should I? All right, come on over. You're going to add flour into here until it reads 300 on this.
So by volume, you're adding...
I think it's probably about 2 to 1. I don't know. We can also look at what Isabella's looks like. Scoop it in.
So I can zoom in on Isabella's fingers.
Yeah, it's pretty thick. So like it's not like watery. It's like a little glumpy. So you're gonna add some water so it's not super watery, a little glumpy. Yeah, great job, Georgia.
Can I eat this?
No, we're not gonna eat it. A little bit more, Georgia.
Is that dough?
No, it's not dough. It's just flour. Isabel's is just flour and water.
Frozen raisins?
Yeah, frozen raisins should work just fine. 300. So we get a little bit more.
How many raisins?
Georgia added like a handful. We'll see. I'm in this with you guys. I've never made a sourdough starter before. But I've seen online that raisins is a great way to get it started faster. Ooh, you're probably only going to need like a scoop.
So definitely pay attention to where you start and what you did so you can tell us how your experiment goes.
Yeah, I mean, everything I've seen, you can use instead of raisins, you could use like wine, you can use beer, you could use old pizza dough, all sorts of things that have sort of a more natural yeast in them. So Georgia has added, again, equal parts by weight of flour and water to her raisins. And then you're going to go grab a spoon, Georgia, and you're going to mix it up. All right. And Belly, can you please wait, Isabel? Georgia, can you go get a spoon? And then that is what we have for today. We're going to come check back in with these. We actually have to feed our starter every day for the next 5 days, which is perfect because we're together every day for the next 5 days. Woohoo! So I'm really excited because I've always wanted to do this. Yeah, you're going to stir yours up. And I've never felt like I could because I always thought I would forget. And now that I'm with you guys will not let me forget, which I'm excited. All right. So yeah, we're going to just keep this warm. I don't think we're going to see much today, but as we keep feeding it more flour and more water, we should see the yeast starting to populate. And as it eats the sugars, it's going to eat the sugars and it breaks the sugars down to get energy into its own body. And then it farts out carbon dioxide. It sort of breathes by doing oxygen and the sugar. It blends those two to breathe and then it exhales that carbon dioxide. So we'll see the bubbles start to form hopefully in a few days.
All right, a couple questions. Do we need a lid?
Do we need a lid? I don't think you want a lid. We're going to actually put our kitchen towel over the two of them together so that it can still breathe. It does need oxygen because it is a living creature. Yeah, yeast cells are single-celled organisms similar to bacteria, but not. And I know Naomi's going to ask me why they're different. And I'm ready, Naomi. They are different because bacteria do not have a nucleus. So they have their DNA sort of floating around and there's no like central brain. Yeast have a nucleus with this DNA. So they're like much more central. They're more similar to animal cells than bacteria.
So the Zoom classroom is open for more questions.
Awesome. Yeah. So
Kaya is here. Hi, Kaya.
Oh, yay, Kaya's here. All right. So we're going to switch over into our Zoom classroom for lunch. Thank you guys for joining us today. If you are joining us and you want all the downloads and access to the Zoom classroom, we are on Patreon, so patreon.com/RosieResearch. And you can support us at any level to get all of the fun goodies that we're getting. And it only charges you once per week when we give you like the whole menu for like what we're doing every week. So then all the other emails are sort of just to help you remember we're about to have class. So I just want to say thank you guys for joining us. Make sure that you share our science with everybody you know because we are having so much fun. We really are. I mean, honestly, who would have ever thought you'd learn about phase transitions by eating brownie sundaes? Who would have thought? And make sure you like our page, spread the word, and we will see you over in the Zoom classroom. So thanks so much for joining us, and we'll see you soon. Yeah, this one's not very good. It's like burnt. All right, Georgia, you've done a great job stirring too.
What about you, Georgia? Should we try it?
Yeah, we can try Georgia's. But Belly's didn't work. Would you want Belly to share with you if yours hadn't worked?
Can I still get more of it? Yeah, because...
Oh, Belly is even okay with that. All right, we're going to check bubbles.
Belly, you can taste it.
I think this one already has bubbles. Interesting.
Wait, Georgia, not yet. Bring it over.
All right.
With the hot pack.
My Zoom friends, we're going to come over in just a moment. As we're getting set up for the Zoom. Awesome. Do you want to bring me my computer for this?
No, it's not going to be yours. Yours, I know you see it, but your microphone doesn't work.
Oh. Interesting.
But you can still use mine after I leave this stream. And they can still hear you.
You could probably just fold it and break it. You're just gonna crunch and break.
As usual, friends, we're getting
If it's not breaking yet, that means it's not actually fully dry. So you want to just give it some more time to cool off a little more. Because it should shatter like glass. Yeah, see, it's like, oh yeah, this one's gonna need a little cleanup. Clean up on aisle 3. All right, my Zoom friends, we are working on getting it set up. My computer broke a little bit this weekend, so it doesn't have sound or a microphone, which is really odd. I'm not sure why.
I think it's the same. Oh, it doesn't. You can't hear anything out of it either.
No, it doesn't have speakers. Don't work. I'm not sure what's going on.
All right.
So we're working on getting it on Evan's computer, but we'll be here for all your questions and lunch, obviously, in what moments.
Looks like glass.
You know what you could also do right now when it's warm like this? Oh yeah, yours is still really warm. You can shape it, and then we can peel it off later, and it will come out in that shape. And that will, to see if you feel it, it's still pretty
Isabella,
warm.
can you hold this computer like this for a second?
Why?
Just hold it here for a second.
See how warm that is?
And then as I move this forward,
So we want to wait until it's
the
warm.
computer forward and set it on the table.
Well,
Shoot!
try it. Can I be the
Thank
one to
you.
try it?
Yeah, but it's just not ready.
And we're gonna end it.
All
It
right.
looks like plastic.
Oh, are we still live?
We're still live. You're on. I can hear you.
I'm gonna end YouTube.
And then you're gonna end your spotlight of your other video.